All right, so last night we talked about scientific notation, and today we're going to be learning about how to multiply expressions that have exponents. So before we jump in, there are a few rules that we need to have to set in place for the answers that we're going to get when we multiply expressions with exponents. And those are that there are no negative or zero exponents in your answer. So no 0 or negative. And that looks like anything like x to the 0 or 4 to the negative 2. We don't want any negative numbers or 0 in our exponents. The second is that the same base doesn't appear in a product or a quotient. So a product or a quotient. And that looks like if you have like y to the 3 times y to the 4, we want to be able to reduce that. We don't want to leave that in our final answer. Our third one is that no powers, products, or quotients, so no powers, products, or quotients are raised to powers. So what that looks like is you don't want to have like x to the 4th raised again to the 3rd. We want to only have one exponent at the most, and we don't want to have something like x times y all to the 3rd, something like that. Or we don't want to have like y to the 2 over y to the 4 all to the power of 5. We don't want anything like that. And our fourth rule is that numerical coefficients are completely reduced. So numerical coefficients are completely reduced. And what that looks like is if we have something like 8 squared times 3 to the 4th times xy, I want those two numbers to be 1. I don't want to leave them as 8 squared and 3 to the 4th. But we'll see what that looks like. Let's do some examples. Okay, let's jump into some examples. So there's one rule before we go into this that I want everybody to keep in mind. That is, when in doubt, write it out. So if you're unsure about an answer, write out your entire problem. So I'll show you what that looks like. Our first example here is x to the 3rd times x to the 4th. So x to the 3rd we know is x times x times x. So when in doubt, write it out. I'm going to write out the whole thing. X times x times x times x to the 4th, which is x times x times x times x. And you can see this as 1, 2, 3, 4, 5, 6, 7 x's. So my answer is x to the 7th. My second problem is x to the 3rd all to the 4th. This means when I have my parentheses that everything in here is going to be multiplied 4 times by itself. So I'll have x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. That's 4 times of what's in there. So I'll get x times x times x, looks like a minus, so times x times x times x. You can guess this is going to be 4 times. And my answer is going to be, I'm going to have 12 x's here, so this is going to be x to the 12th. That's my answer. Notice that these two are not the same. When we had x to the 3rd times x to the 4th, it was x to the 7th. But x to the 3rd all to the 4th is x to the 12th. All right, our third one, 3x squared to the 4th. So similarly, everything that's in these parentheses, we're going to be multiplying by itself 4 times. So that's 3x squared times 3x squared times 3x squared times 3x squared. You'll see where I'm going with this. And when in doubt, write it out. If you're unsure, write out the whole thing. You might be able to come up with some rules for yourself, but I'll leave that to you, and we'll try some in class. So this will be 3 times x times x, 3 times x times x, all multiplied together. And even though I have parentheses here, if all I'm doing is multiplying, this means I can multiply this times this times this times this. I can take separate elements and multiply them by each other. So 3 times 3 times 3 times 3 is going to be 81. And I have how many x's? 1, 2, 3, 4, 5, 6, 7, 8. So x to the 8th. 81x to the 8th is my answer. All right, let's do some more. Okay, we have several more examples. And for the sake of time, I took the liberty of writing all of these out, but I will go through them one by one. So the first one, we have 6a squared b times negative 3ab to the fifth. So this will be everything written out. Looks like 6 times a times b times negative 3 times a times 5b's multiplied together. So I would, just like you know when you add like terms, we're kind of going to multiply like terms here. So I have numbers, 6 times negative 3, which is negative 18. And then I'm going to count up how many a's I have. So I have 1, 2, 3. So that's a to the third times how many b's? 1, 2, 3, 4, 5, 6. B to the sixth. So my answer is negative 18, a cubed, b to the sixth. And notice I said cubed there. When we say a to the third, sometimes we say a cubed, just like we say a squared when a is to the 2. So our fifth problem, we have 8 to the fourth times 8 squared times 8 to the 0 power. So we have 4 eighths multiplied times 2 eighths multiplied. And this one is 0 eighths multiplied. So if we have 0 eighths, it's really like multiplying the rest of this by 1. And if you remember, anything to the 0 power is 1. So my answer is going to be, how many eighths do we have here? 4, 5, 6, 8 to the 6th, which is actually 262,144. All right, and my sixth problem, 4 squared p squared, all to the third. So that means I have 4 squared p squared multiplied by itself 3 times. And when in doubt, write the whole thing out. If you're unsure of what your answer is going to be, better to write it all out. So I have, how many 4s here? I have 1, 2, 3, 4, 5, 6. So that's 4 to the 6th times p, and how many p's? 1, 2, 3, 4, 5, 6. P to the 6th, which is, the number is 4096 p to the 6th. And that's my answer. All right, let's do several more. Okay, this next one is a bit of a doozy, but we have 3x squared times y to the 5th, all squared, times 2x y to the 3rd, all cubed. And this, when we write it out, we're going to have 2 of these first terms in parentheses here because we have an exponent of 2, and then we're going to have 3 of this second term here. So 3 of those. And when we write it all out so that we can see it, we have all of this. So what I'm going to do is multiply my numbers together. So 3, 3, 2, 2, 2, and I will get, what is that? 3 times 3 is 9, times 2 is 18, times 2 is 36, times 2 is 72. So 72 times, and now I have to do how many x's I have. So I have 1, 2, 3, 4, 5, 6, 7, x to the 7th. And the y's, I have 5 here, plus 5 here, so that's 5 and 10, 13, 16, 19. So y to the 19th. So my answer is 72, x to the 7th, y to the 19th. All right. Now let's do a couple more problems, maybe some with some words and some scientific notation. Okay, so problem number 8 says, the radius of a circle measures 3x to the 4th inches. Find the area of the circle. So before we get started, let's just do a little review here. If we have a circle, my radius is going to be the distance from the center of the circle to an outer edge. So that's my radius. So that distance is going to be 3x to the 4th. And we also need to know something about the area of circles. The area of circles is pi times r squared, where r is our radius. So if we know the radius, and they tell us the radius is 3x to the 4th inches, we can plug that in for r. So we know r equals 3x to the 4th inches. So in a equals, where area equals pi r squared, I'm going to plug in 3x to the 4th. So I have pi times 3x to the 4th all squared, and it'll be inches squared. So I'll have, what does this equal? Well, we have pi times 2 of these multiplied together. So 3x to the 4th times 3x to the 4th. And when in doubt, write it out. So if we write out the whole thing, we'll get pi times 3 times x times x times x times x. And again, 3 times x times x times x times x. And now we get to do, so we'll have pi. I'll leave pi as pi. that's okay. 3 times 3 is going to be 9 times 9. And x, how many x's do we have? We have 4, 5, 6, 7, 8. So x to the 8th. And sometimes in math, we like to put the numerical coefficient before pi. So we'll have 9 pi x to the 8th. That will be my answer. And my units will be inches squared because I squared my length of 3x to the 4th inches. All right, so let's do one more. All right, so we're getting a little biology here. In this problem, we're told that a newborn baby has 26 billion cells, and that an adult has about 1.9 times 10 to the 3rd times as many as a baby. So they have 1.9 times 10 to the 3rd times as many cells as a baby. So about how many cells does an adult have? Well, there are a few things we need to do here. Let's look back at this number up here. I don't really like all those zeros, and we learned a technique for getting rid of those. It's called scientific notation, and if you think back, this we can simplify to 2.6 times 10 to the 10th. So I'm going to use that. And I'm going to say, all right, so an adult has this many times as many as a baby, so I'm going to take whatever a baby has and multiply it by that. So I will have 2.6 times 10 to the 10th cells multiplied by 1.9 times 10 to the 3rd. All right, so we're going to have to do a little multiplication. Bear with me here. I'm going to speed this up a little bit. Okay, and we're back. So what we're going to do here is multiply these first two terms. So 2.6 times 1.9, which is going to be 4.94. And then I'm going to have to count up how many 10s I have. So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 4.94 times 10 to the 13th cells. And that is how many cells an adult has. All right. So now I will leave you to try those problems at the bottom of your guided notes. Thanks for watching.